This is mathheals.com, where you can find more links to math YouTube videos. And let's take a look at vectors. Now a vector, let me take a look at first one here. We got W. Looks like that. And we got U. More or less looks like that. And then we got V. Looks like this. Now, these are 3 examples of vectors. A vector has a certain distance that goes along with it. We'll see that's called magnitude. And it's got an angle it's at. See how this angle is different than these angles over here? It's got an initial point. It's got a terminal point. Vectors are used a lot in physics. Now these first problems want us to do geometric operations using these 3 vectors. So we got U plus V. Well, doesn't matter where you start. I'll start right here. U. Well, that'd be about this distance, not that far, that angle and so forth. So now where this one ended, then we're going to do plus V. So we'll do this distance at this angle. Not that I can't draw a straight line, but that was supposed to be the same angle, same distance as this. So this is U, and this is V. Now this was our initial point, and this is our terminal point. So this right here, this vector, is our U plus V. Now oftentimes you see vectors written in bold in books. And here I couldn't really bold this because of this being an equation editor. Or, no, that was in the picture. Never mind. Actually, I could have bolded it there. I guess it just didn't do it. So sometimes you'll see they'll put little symbols like this over there to indicate vectors. Now I'll get sloppy about that in this section. Everything we're working with is vector based, so I don't need to worry about that. But again, those will be vectors. Let's look at our next problem. Next one is 4V. Well, it's gonna, here's V, so I'm gonna go 4 times this, so distance 4 times that at that angle. So here's right there. There's 1 V. There's another V. There's a 3rd V. And there's a 4th V. So our answer is that right there. That would be our 4V. And again, I'm not going to put those symbols out there. We know we're dealing with vectors. Okay, number 3. W minus V. Well, W is this distance, this direction. I'll start it down here. And so we're going to go out like that. And that's our W. Now minus V. Well, V would be from that point where we ended off. V would be going down like that distance. Since it's a minus, we go in the other direction. So we're going this way. I don't know why I can't draw a straight line. Like that. That's our minus V. Now we use these just to figure out where the terminal point is. Now this is always our initial point. So now I draw a line between those. And now it would be our W minus V. All the rest of that isn't part of your answer. Just what we see right there in the red. Okay, next one. You got 2w minus v plus 3u. 2w minus v plus 3u. Okay, I think I got an idea of where. You have to make sure you have enough room. 2w. So I'm going to go out this direction, and a distance twice as much as that. Yeah, it's probably not too bad. That's our 2w. Okay, minus v. Well, v would be down like this, so minus v would be going this direction. And that's as close as I'm probably going to get to it. 3u. Well, u is going down. See the arrow tells you which direction it's going. And I will go down, and I will go 3 times that distance. So there's like 1u, 2u, and maybe 3u. I mean, it's probably as close as I'm going to get. Okay. Now this was our initial point, and this is our terminal point. So this would be our vector. 2w minus v plus 3u. And that's our answer. Let me save this. There we go. And let's look at our next problem. Now here we're given 2 points, and it wants us to come up with a position vector. Now this is very straightforward to come up with. It's just a formula. Given your initial point, x1, y1, terminal point, x2, y2, your position vector is just subtracting the x's, x2 minus x1, and subtracting your y's, y2 minus y1. Okay. So we got negative 5, 4. And we got q is equal to 3, 2. And p is our initial. And this one's our terminal. So this would be x1, y1. That's our initial point. And our terminal point is our x2, y2. So our position vector, and I'll just use v, I guess. Oh, they do say use v. Okay, never mind. V is going to equal to x sub 2 minus x sub 1, and y sub 2 minus y sub 1. Well, x sub 2 was 3, minus x sub 1, which is negative 5, y2, which is 2, minus y1, which is 4. So we got 3 plus 5, and 2 minus 4. So that gives us 8, negative 2. Now notice the less than and greater thans we have around there. That's a vector. So you see that's vector form. Now I can take that and split it apart into 2 separate vectors. That's one of the operations you can do on vectors. You can add 2 vectors together. Well, going backwards, you can split them apart. Like if I went from here to there, I'd add together the first parts, 8 plus 0, and add together the second parts, 0 and negative 2. Now I can also factor out a number. So I can factor out an 8 here. And here I can factor out a negative 2. Now this this 1, 0 you see here, that's a unit vector. 1, 0 would be this vector right here, if I think of it graphically. It's along our x-axis. Now the other one, 0, 1, that would be right here. And that's along our y-axis. Both of these are unit vectors. They got a distance of 1. And here we use I for this unit vector. -2, and we use j for that unit vector. Now again, they usually are bold, or they'll put the little vector symbol over there. I think that becomes pretty sloppy if you put it too many times in your work. But again, if we were in physics, it'd probably be real rigid about that. And this would be our answer. Now it's not hard to put it in that format. If you got with the less than and greater than around here, see how we just got 8i minus 2j. That's the way it always works out. So now, if in case you're wondering about this vector here, we got 8 and we got -2. So 8, -2 would be down to here. Now, and that's based upon the origin. Realize that if I pick two different sets of points, and another two different, I may get the same vector here, the position vector. Now, if you don't have any of the initial points of where it started at, then we just automatically go from the origin. But if you had this, and you had one of these points, you could work backwards. Let's talk about this. Looks like the double absolute value. This is the magnitude. Also known as distance. But they have a fancy fancy word for it in terms of that. Well, let me got a vector here. Goes like that. And this right here is our distance of it, magnitude. Well, if I come down to here, and I have this on my x and y axis, v is equal to ai plus bj. A and b are constants, and I and j are vectors, and v is a vector, of course. Well, this is a right triangle. So to find this distance, we can use a Pythagorean theorem. Now, this right here is our x values, which happens to correspond with our a's. This one's our y values, which happens to correspond with our b's. So to find our magnitude, we're going to take the square root of a squared plus b squared. That's just based upon the Pythagorean theorem. You know, if I had the magnitude squared equals a squared plus b squared, drop the squared, and we put a square root around the other side, that's how we derive our formula. So that's going to be what we're going to use for these problems. So let's look at this one now. We got v is equal to -2i plus 4j. And it says find the magnitude. Well, we're going to take the square root of -2 squared plus 4 squared, which gives us 4 plus 16, which gives us 20. 20 is 2 times 2 times 5. Remember, the square root, we're looking for a pair of numbers, so here's a pair of 2's. Those are going to come out in front as a single 2. So we got 2 square root of 5. Now, if we were actually using that to graph something, we might want it in decimal, but that's our answer. Let's take a look at another one. We got v is equal to 4i plus 6j. And I want to find the magnitude again. So it'll be the square root, and we're just using this formula here. So 4 squared plus 6 squared, which gives us 16 plus 36, which is 52, which is 2 times 2 times, that's 4, 1, 13. Looking for pairs of something. Here's a pair of 2s, so those are going to come out as a single 2. And our answer is 2 square root of 13. Let me save that. And grab a drink while I'm at it. Okay, let's look at this one. We've got V is equal to 7I minus 3J, and W is equal to negative 4I plus 6J. Now, we could write that if we wanted to, this in this form: 7, negative 3, and negative 4 and 6. But by having it in this form, it's so much easier to work with, because we can think of these as variables. They're not, but we can think of them as variables, and then just do a normal operations. Combine together like terms, all of that. So let's take a look at 5v minus 3w. Now, instead of doing it geometrically, we're just going to do it algebraically. So where the v is, we'll plug in 7i minus 3j. Where the w is, you plug in negative 4i plus 6j. And again, we treat them just like variables. 5 times 7 is 35i, using distributive property. 5 times negative 3 is negative 15j. Negative 3 times negative 4i gives us a positive 12i. Negative 3 times 6 gives us negative 18j. Now we want to combine together. You can think of them as like terms or not, but same concept. Here we have 35i plus 12i. That gives us 47i. And here we have negative 15j and negative 18j, negative 33j. And that's our answer. Okay, let's look at this one. Number 9, we have v is equal to negative 5j. And it says find a unit vector in the same direction as v. Our formula is u, let's say u for our unit vector, is equal to v over the magnitude of v. Well, what are we finding here? Negative 5j. Well, if this is negative 5 there, what am I thinking? Try that again. I is along here. Negative 5 is, or j is along here. So negative 5 would be down right there. So there's our vector. And we want a unit vector. Unit vector means a distance of 1. In the same direction as this. Well, this one is pretty easy. If I want it in the same direction as this, and I want it to be a unit vector, then it would look like this. And I see that my unit vector is negative j. But let's go through our formula. So v is negative 5j over the magnitude, which is the square root. And normally I'd square the number before the I and square the number before the j. But there is no I, so I'll just square the number before the j. So that gives us negative 5j over negative 5 squared is 25. And square root of 25 is 5. And the 5's cancel, and we got negative j. So that's our unit vector. That one was kind of boring. Let's look at a little bit more exciting one. So we got negative 4i minus j. If I were to graph that, negative 4 and negative 1, there's our vector. Now we want to come up with a unit vector, distance of 1, that's in the same direction as this. This is our formula, v over the magnitude v. So we got negative 4i minus j over the square root, and we'll square the number before the I, so square the negative 4, and we'll square the number before the j, which is negative 1. So that gives us negative 4i minus j over square root of negative 4 squared is 16 plus 1, which gives us negative 4i minus j over square root of 17. Split this up. We got negative 4 over square root of 17i minus 1 over square root of 17j, which gives us negative 4 square root of 17 over 17. I multiply top and bottom by the square root of 17 minus square root of 17 over 17. Again, multiply top and bottom by the square root of 17. And this is our unit vector that would be in the same direction as this, but it would be a distance of 1, wherever that would fall. Let me see, what was that initially? Negative 4, negative 1, and then that gave us square root of 17, which is about like distance of 4 point something. So that'd be about right here if I had to guess. Now that's used in other formulas. So you find a unit vector, and then you can take that to help you calculate with other problems. Now this one says write the vector v in the form ai plus bj given its magnitude and the angle alpha it makes the positive x-axis. So tell us the magnitude is 4. Alpha is equal to 30 degrees. And our vector v is equal to the magnitude of v times cosine alpha I plus sine alpha j. Now that probably looks a little bit familiar, doesn't it? Remember our polar form from earlier? We said r cosine theta plus I sine theta. Now realize here this I before your sine is the imaginary number. The I here is a unit vector. So they're different. But think what these represented. R, that represented our distance, didn't it? Well, magnitude, that represents our distance. Theta represented our, starting over here with this side here, our angle going up. Well, that's the same thing that alpha represents here. And then cosine was our x-axis. And over here, remember our I, our unit vector, that's based upon our x-axis. And then j is based upon our y-axis, unit vector-wise. And sine is based upon our y-axis. So they tie hand in hand. So there's nothing new about this formula. Okay, so we plug in 4, and then we got cosine of 30 degrees I plus sine of 30 degrees j. Okay, well, I look at cosine of 30 degrees. That's square root of 3 over 2 I, plus sine of 30 is 1/2 j. Multiply the 4 through, and we got 4 square root of 3 over 2I, plus 4 over 2j, which gives us 2 square root of 3I plus 2j. And that's the vector that goes along with that magnitude and that angle. Okay. Now this says find the direction angle of v for each vector. And what are we talking about there? Well, we're talking about, let me graph this. Negative 2I plus 2j. Negative 2I. Remember, the I corresponds to your x-axis, and j corresponds to your y-axis. So negative 2, positive 2 would be right here. So that's our vector. And we're trying to find this angle right here. And to do that, we're going to use this formula. We may have to do some adjusting once we get there, but that's one we're going to use. Well, this is A, and this is our B. So our formula says tangent, is it theta? Alpha. Okay, I was thinking of using alpha here. I should probably actually put alpha over here too then. There we go. Tangent alpha. Now remember what this was before. Tangent is equal to y over x. Y corresponds to our j, that unit vector. So we're going to put b over a. So tangent alpha is equal to 2 over negative 2. Now I can take inverse tangent on both sides, arctangent. So we take inverse tangent on both sides. Excuse me. 2 divided by negative 2 is negative 1. So we got alpha is equal to inverse tangent of negative 1. Let's go put this in our calculator. Though this is one that's on unit circles, so you could do it that way, but make sure you're in degrees. So I'll press my mode. And if yours doesn't have degrees marked, you down arrow to that line, right arrow, put your flashing cursor on degree, and press enter. And then second mode to exit out. Okay, so inverse tangent, so second tangent. That's also arctangent if you learned it that way, of negative 1. And we get negative 45 degrees. Now remember, with the inverse tangent, the only places the inverse tangent works is this quadrant and this quadrant. Well, if we looked at where our point was, the negative 2, 2, that was in this quadrant. So this is where our vector falls. We came up with negative 45. Well, negative 45 is over here. That's my negative 45. I want it to be over here. So what I'll do is I'll add 180 degrees to that. And I think that's 135. So alpha is going to equal to 135 degrees. And that's the angle. So again, you use inverse tangent to find your angle, but then you may have to do some adjusting once you get it. Let me save that. We got V is equal to 3I plus, and I got a negative, I don't know why I did it that way, but minus 7J Well, let's first graph this, just kind of get an idea. What are we looking for? Okay, 3i. So we go 3 on our x-axis. Negative 7j. So we got negative 7 on our y-axis. That would be our point, 3, negative 7. So then our... Well, I didn't draw that real good, but there's our vector. So our angle is this right here. Okay, well this is our A, and this is our B. So then, we got tangent alpha is equal to B over A. Tangent alpha is equal to B, which is negative 7, over A, which is 3. We'll go ahead and take the inverse tangent of both sides. Arctangent, if you learned it that way. There we go. Those cancel each other out, and you got alpha is equal to something. Let's see. Second tangent, negative 7, divided by 3. Negative 66.8 degrees. Well, negative 66.8 would be this right here, which is correct. I mean, that's where we want our vector at. But over here, and I put this, alpha has to be between 0 and 360 degrees, not including 360. So, since we came up with a negative angle here, what we're going to do is we're going to add 360. Because we want this right here. I mean, this isn't the correct position. We just need to have this between 0 and 360. So we add 360, and that goes all the way around, and we're back to where we were. And I have no clue what that is, so let me go over here. Negative 66.8. Try it again. Negative 66.8 plus 360 degrees. 293.2. So alpha is 293.2 degrees. And that's our answer. And I think that was the last problem. So let me stop the recorders. Save this.